Next up, we have Dale Kelly of JC Renfroe with a presentation entitled Design Category C. During Dale's presentation, please post your questions in the Q&A module, and Dale will answer your questions at the end of his session. At this time, I'd like to turn it over to Dale and JC Renfroe.
Good afternoon. Thank you, Justin. I'd like to discuss Category C of the new ASME BTH design class. This came out back in July of 2017, and it's a more robust class for under the hook lifting devices, specifically the Renfroe clamps. Where I left off, the Category C is part of the ASME BTH 3020 that was released just in the last 2 years. It governs the clamp safety standards that we use to both design and inspect and provide guidance to the operators. It's part of the ASME, and the BTH one is what the engineers are using to design to the standards so that the clamps meet the standards. Everybody's good now, you can see me, right? Okay. Just to review a little bit more, the ASME is the main grouping that these two specifications belong to, and you have the two different books and two different codes that represent the operators, which is the below the hook lifting devices 3020, and the design criteria BTH-1, and that's what the engineers and the manufacturers are using. This is kind of the overview of what both the books look like, just to kind of give you an idea if you're out and about, or if you have see them, you'll know what you're looking for. And there's they're pretty thin, about 30-40 pages each. So what they try to tell you is in the ASME BTH-1, each clamp has assigned a letter for the classification and a number. The design category controls the intensity and the level of safety that the clamp is designed to, A, B, or C, C being the new class. The number is the service class, 0 to 4, and it indicates the number of cycles that the clamp is good for. The up to 2 million and above, class 4 being the highest, and that's above 2 million cycles, excuse me. The combination of the two gives you a basic information about the clamp, about its robustness, about the longevity. If you have a clamp that's categorized as a design category A, that would be 2 times the working load, and it must hold the load. A category B would be 3 times, and the new category, class C, is actually 6 times the working load. As I indicated before, the service class is a number that represents the number of cycles the clamp should be rated for that it will see in its lifetime. Again, class 4 is over 2 billion cycles. Very, very robust clamps. Each clamp must have this rating marked right on the clamp or the clamp tag. As you'll note here, the service class and the design category on the Renfroe clamp is at the base of each of the tags, and it's pre-marked from the factory to indicate the design category as well as the service class. And the primary rule in the ASME is that it must be stated on the clamp to meet the category, to meet the specification. It's part of the identification information. What does it really mean? A lot of people really don't understand the meaning of what these design categories and service class means. So I tried to break it down from a user's point of view. A clamp A is a clamp that's rated for known lifting conditions, such as a laboratory environment or a factory environment where it's a repeated cycle, a day-to-day repeated type of cycle. It's not a very severe environment, mild conditions. The loads are pretty exact, like a production floor or factory where a conveyor belt lifting situation or in those type of lift situations. You know the number of cycles so that you can calculate with a fair amount of accuracy the life of the clamp based on those cycles. It's repeatable conditions as well. Non-severe environments. It's not the areas where you have high caustic chemicals, sandblasting and such. And it has minimal shock loading by utilizing slow lifting. A clamp that's rated in the design category B is rated for some more severe environments and more severe loads. It has a higher working load safety limit, and the loads are not certain. It has an unknown number of cycles possibly, and it's a less controlled condition. It may see more dynamic loading, more impacts, maybe used in forging type applications and such. Overall, it's a more of an industrial environment where possible chemical contacts can come into play, or sandblasting environments, conditions that are a little more harsh. The new class is an extremely robust clamp, and it's rated for use with machinery and known harsh conditions such as outdoor usage where it's stored outdoors, say near a saltwater estuary, or ocean conditions on an oil rig where the salt environment is really harsh, or in a chemical booth, like a stripping environment where it's known to strip paint and such. The loads are also known to be extreme. Forging and forming operations are quite common for the type of clamps that are used and rated by this new category. Also, the number of cycles could be low and very high loads, or it could be less controlled conditions where you're more apt to have impacts and severe shock loading. It also includes very severe environments and faster loading for more an impact of dynamic loads or high loads in general for the most of the life of the clamp. So the Class C is a very robust situation. It's a 6-to-1 safety factor now instead of the 3-to-1 as in Class B. And it provides the user a more realistic reading of the clamp if he's using it with a such as a forging operation or bending operations where the clamp's going to be on the plate during the forming or forging operation. This would be the clamp most likely to be used for that type of situation. All right. Some of the testings that we have done is we tested 9 clamps in a cycle testing environment to provide the longevity and to kind of judge the rating numbers themselves to see how they stacked up against the real life data. As you notice, the first 2 are our clamps. We chose 7 of the clamps just at random, just to try and get us a broad spectrum to see how the ratings stacked up, plus to compare ours to theirs. As you'll notice, we tested, in our case, the L series clamp, model L, and the J series clamp. The J series has a C4 rating, and you'll notice that the ultimate failure is a 7.2-to-1. Now the clamp actually was higher than that. In real life, it's higher even than the 7.1. So it earned a C4 rating in this test. The rating of the L was a B3. So this is our lighter weight series. We still feel that's pretty adequate for most applications. And we put all of our clamps that we tested, went through a series of cycle testing, both in the horizontal and vertical modes, and we tested them until they failed. And the brands listed here, just showing you the different ratings. You have a B2, one was unknown, one's an A0, one was another unknown, and one was a B0. And what I've done is I've summarized the data just to kind of give you an idea of, well, what does a B3, what can I expect from a B3 versus a C4, just to kind of give you an idea in the next slide after this. The clamps with the higher lifter classification are usually stronger and last longer. The new lifter classification will reflect our legacy of strong clamps. We've known for years that Renfroe was pretty robust, but the B category only went so far. So this new category, many of our clamps will be moved into this Class C category. As I said before, the history dictated that B4 was the highest we could go, but now we can move these over, and we're re-rating our clamps as of this moment to this new C class. We've already moved 231 clamps into this category, and they'll be reclassified as design category C. And I might add, this needed no additional design changes to do this because the clamps were pretty robust to begin with. As I mentioned earlier, they have the greater ability to withstand shock loads, and our clamps are repairable. And I'm not trying to make this about our clamps. It's just the A clamps tend to be non-repairables with certain features in them that once they wear out, there's not much you can do with them. But Renfroe's clamps and other brands have a repairable parts in them. They get the B rating because they can be torn down and replaced and rebuilt. These test results prove the ratings do mean something, and as you'll see in a moment, they provide an actual measure of the quality and the robustness of our clamps. Starting with our Model L, you'll see it was a B3. It didn't quite make enough to make the 4 classification above 2 million cycles. In the horizontal test mode, it meant basically 1.6 million cycles. It did make 2 million in the vertical cycles. So it made a B3, which is the classification from 500,000 to 2 million. Excuse me, 1 million, I'm sorry, 1 million to 2 million cycles. Above 2 million, it would have been rated at 4, but it fell just quite short. And we felt comfortable with that because of the fact it's a ergonomic type of clamp. The Model J, or the JPA, as I mentioned earlier, went a full 3 million cycles, and we stopped the test. It didn't really fail. It earned a full C4. And the rest of the classes, you can see they corresponded to the actual working data. You had brand A that went 744 for the class 2, so it met its rating. Vertical went 2 million. B2 was a horizontal test that failed at 899, and vertical at 100, so it met its rating. The brand C was an unknown clamp, unknown rating, but it went full 2 million cycles, and so forth on down the line. The worst clamp was the B0, although it met its rating because 0 to 100,000 was the 0 to 20,000 for the cycles. Its horizontal was 79,000. So it just shows you that these numbers do represent real life data and how they can hold up during testing. So that being said, we try to live by these numbers. We rate our clamps accordingly to give the user a good representation of the quality and the robustness of the clamp, and we feel like these testing kind of bear that out. As a summary, I pulled up the ones that failed. Again, brand F was a B0. It pull tested 5 to 1 as well as the other 2. Ours went to 11,000. It has a B3. So all of these clamps were making 5 to 1, which is again above B. But the second part of that is the number of cycles it has to pass. So they didn't quite make the full number of cycles that you see down here in the horizontal testing. It was 79,159 to 1.6 million. So the numbers do kind of correlate to the service class, and it gives you an idea of the life of the clamp under certain conditions in a laboratory. This is the type of areas where they failed at, mostly in the shackle areas. They develop cracks. After this many cycles, that's understandable. Just to kind of show you that we did a post-test analysis to ensure what actually broke down and failed to make sure the test was accurate. One of the clamps actually failed in the body, in the jaw area. And as you can tell, it still met its ratings, but just you know, showing you the data just to verify the test numbers. And this was brand A again, had the crack. So Renfroe exceeds the standards. Our new design accord reflects investment grade type hardware where it's field repairable. The repair kits are available. It also represents that our clamps have been stronger and last longer for many years. J.C. Renfroe has been a leader in the industry, and we've got over 70 years of experience. The clamps have a 5-to-1 or higher safety factor, and this new C class confirms this. And so, as I mentioned before, we have 231 clamps that are being reclassified, and that's an ongoing effort. That's part of my job, is to look at all the designs, do what needs to be done, either testing or analysis based on data, not just speculation. We actually, if it's needed, we will pull test and break these clamps, or we'll repeat the cycle testing as needed. So it's kind of it's an ongoing process. It's not a cheap process, and it's a slow process, but we feel it's well worth it because of the design standards that reflect our clamps are now kind of catching up to the Renfroe side of things. The FR halves, ones, the J's, all of these are some of the ones that have already been moved into this new category. And you know, this will continue on until the selection and the new clamps kind of catch up to the standards. Some of the actual pull test values on some of our higher rated clamps, as you can see, were quite high. Under destructive testing, we were able to get the FR half ton to 21,000 pounds. That's a 21 design factor. So as well as the rest of these, you can see that many of these numbers far exceed the maximum 7.2 for or the minimum 7.2 that's allowed for the standard. This just kind of shows you just how robust a Renfroe clamp really is, and the design is very sturdy. The J2 ton, it pulled at almost 40,000 pounds. So that's why we felt like this was an effort worth it to the cost to provide this data, so that we can take advantage of this new class. We always try to rate our clamps with a true service class rating. We use an independent lab, Renfroe Innovation Services out of Wisconsin, to do our testing for us. So it's not just us saying this, is we've got validated test results from an independent company proving out the tests were valid. In addition to that, all our clamps are proof tested when they leave the factory at 2-to-1. The new design category of the 7.2 failure, many of our clamps have already met this and really don't have to have any design changes other than just being reclassified. Those were the easy ones. That's the 231 they got done so far. We feel like we have the highest design factor and service class in the industry in all but one of the series. That's the L series, which is a lighter weight and higher than many of our competitors. We also offer a lifetime warranty on non-wearable items, and we provide repair service or factory training for on-site, and we offer repair kits and support through nationwide distributors and sales reps. That pretty much wraps it up. Anybody have any questions or anything?
Yeah, Dale, I don't see any questions for you. So we'd like to thank you for your presentation today.